Thanks for joining, everyone. We'll go ahead and get started now. Today's webinar is to talk a little bit about this exploit and attack campaign around what's being called Felina. We'll talk a little bit about what you need to know to understand the vulnerability. We'll give you some insight into the timeline of events and what has happened so far when it comes to the information security industries and Microsoft's response to the vulnerability. We'll do a brief demo of actually showing you how the vulnerability works, and I'll go through and we'll examine a malicious Word document to understand how you can identify if a potential document is malicious and how you can understand the vulnerability by leveraging tools and capabilities that everybody has on their endpoints. We'll also talk a little bit about current status and what we're seeing in the cybersecurity industry. And then finally, we'll talk a little bit about what you should do in regards to Follina. And then we'll open it up for Q&A. Before we dive in, I'll just mention that my name is Francisco, and I'm responsible for our strategy and detection and research teams here at Kidowski Security. Thanks so much for joining, and let's go ahead and dive in. So, starting with what you need to know. First things first, I'm sure you've seen this quite a bit, but we still see some confusion about what this vulnerability is. It's not a Microsoft Office 0-day. It's actually much more broadly impacting, and it's a 0-day in another part of the Microsoft operating system. So it's not Microsoft Office, that just happens to be the current vector of exploitation that we're seeing around threat actors. And we'll talk a little bit about how threat actors can execute or trigger this vulnerability, leveraging other documents or other ways to trigger remote code execution. The vulnerability actually lies in something called the Microsoft Support Diagnostics Tool, or MSDT. You're going to see MSDT a lot, and we'll talk about what that means in just a second. And as I mentioned, it's triggerable several other ways. Unfortunately, some of the detection capability right now is a bit fragile, particularly if you're relying on looking for just Word documents, or if you're looking for particular ways that this vulnerability is being triggered. And I'll talk about some things that we can do there in just a second. And the good news is that there are some really good working mitigations that are available for us that we can deploy at scale in order to prevent this from being abused. So before we dive into the technical nitty-gritty of how this works, I'll go ahead and just dive into a few things that are important to know so that we have a good understanding about how this vulnerability is being abused and how it works. First things first, this MSDT thing, like I mentioned, it's actually a diagnostic tool that's built to enable the Microsoft support team to run automated scripts and gather additional information about what's going wrong in a Windows operating system. The unfortunate reality of this is that this MSDT program actually allows all of this to happen with very minimal user input or without user input altogether. So what you see on the screen right now is Microsoft's description of this tool, which again is to enable this type of automated diagnostics, automated troubleshooting without the need for user input. And what it does is it triggers a compatibility troubleshooter or any kind of troubleshooter that you've seen in the Windows operating system. I'm sure you've seen this at some point, whether it's running old software on newer operating systems, or if you have trouble connecting to a Wi-Fi network, or there's some sort of issue with drivers and you're trying to troubleshoot a Windows system. This is a really common screen that folks have seen, and this is kind of the underlying subsystem that's being abused in order to trigger this vulnerability. Another thing that's important to understand as we look at the vulnerability more in depth is that what's being abused is actually the protocol handler that executes this support troubleshooting tool. And protocol handlers I'm sure you've seen them, are kind of specific ways that you can say, hey, this application can handle this type of link. And these protocol handlers can be registered on a web browser or across the entire operating system. So if you've ever been asked, hey, what program do you want to open your email if you click a mail to link or an email address? Or hey, do you want Zoom to auto open when you click a Zoom link in your browser? All of this is being done with protocol handlers. So there's quite a lot of them, hundreds of them actually registered in a typical Microsoft environment. And all of them are actually super simple to view directly in the registry. This will become more important later as we talk about mitigations. But what's important to know is that there's hundreds of these things. You can register them on a browser, you can register them in the operating system as a whole. And all of them are viewable easily through the registry, at least in Microsoft Windows 7 and above. Okay, last thing that you need to know is some context before we dive into some of the timeline and technical nitty-gritty. So another thing that's being abused commonly in the current method of actually executing this vulnerability is what's called object linking and embedding. If you ever hear about OLE and abusing quote unquote OLE, it's this, it's object linking and embedding. And what it does is it enables you to embed content or link to other files within your Microsoft Office applications. It's a bit more broad than Microsoft Office, but that's a really good example of it. So if you've ever had the opportunity to embed a chart in a PowerPoint presentation that live updates from an Excel spreadsheet, that actually is using this object linking and embedding technology. You can also embed things like videos and audio and all sorts of things in your productivity and Office files. So this is a really useful technology. Unfortunately, it's actually also being widely abused by threat actors. So for a while, we saw a lot of abuse of macros, and macros are kind of becoming a thing of the past as we work towards doing things like disabling macros automatically on any document that's open from the internet. Microsoft has started transitioning that direction, and in response, threat actors and attackers and pen testers, they've been transitioning to things like object linking and embedding and abusing those technologies. And that's what's being done here, and we'll talk about that in just a second. Before we dive into kind of live reversing a document, the first thing that I want to mention is we're actually in a really interesting point in the cybersecurity industry, because we have a pretty good idea as to what the process went from kind of disclosure of this as an issue, some research and development, and then a threat actor actually abusing this live. So first things first, this entire vulnerability was actually initially disclosed by a bachelor's student at a German university. They were writing a thesis paper about several different ways that you can abuse standard Windows functions to execute malicious code. And in a very long thesis, there was just a few paragraphs about potentially abusing this MSDT protocol handler. And what you see here is that the student in that is actually mentioning, hey, by the way, you can kind of abuse this to load a program from a remote URL. And this is what kind of kicked things off. So originally published in August of 2020, we then see some additional interest from attackers around March of this year. We saw a blog post published about how you can actually trick Electron applications, which are just a type of application that is universally applicable. You can deploy an Electron application on Mac and Linux and Windows. Teams, as an example, is an Electron application. But there was some exploitation of abusing this MSDT bug to essentially get remote code execution in Electron applications. That started happening around March 2022. It wasn't super broad. It was just an interesting blog post, and we started seeing this as a potential vector of attack. Then, interestingly enough, around around April 12th of this year, a organization called APT Hunting Group actually identified abuse of this vulnerability in active attack campaigns by nation state adversaries. It was actually reported to Microsoft in April of 2020, and they unfortunately closed it as not a security issue. The back and forth with the Microsoft person and the individuals who reported it is a little bit disappointing, but it was clear that maybe there was a language gap or a language barrier and it wasn't quite explained correctly. We also then see kind of what kicked off everything lately, which is a Twitter account called NowSec disclosed the fact that this was being exploited in the wild. And particularly what they disclosed is that somebody uploaded a document to VirusTotal that seemed to be abusing this functionality, and it appeared to have been a nation state attacker. And after doing some checking, it looks like this has been exploited, not super broadly until recently, but it was actually being exploited by threat actors at the nation state level. So just a brief overview of this timeline. What we saw was this was kind of published in a research paper or a thesis paper in August 2020. Around March of this year, we saw some abuse of this issue, targeting particularly, again, Electron applications. And then we really started seeing broad visibility into threat actors actively weaponizing this vulnerability and exploiting it in April. And then around May, late May, is when this was reported broadly and publicly on Twitter, which became all of what we're seeing today. It was identified and confirmed as a 0-day by the information security community on May 29th. And then by May 30th, so kind of a few weeks ago, about a week ago, Microsoft officially assigned a CVE ID and published some guidance on how clients should respond. So that's the timeline, about 2 years from discovery to full-on exploitation by a nation state attacker. All right, now, whoops, skipped one. Now we'll actually dive into looking at a malicious document, how we can investigate it, and showing you live how this vulnerability works and how it can be exploited. So let's go ahead and pray to the demo gods as I transition here to 2 virtual machines that I have running. So first things first, what you'll see is I have just a standard Windows virtual machine on this computer. And then I have kind of an attacker system on the side over here. So I've already done some work to prepare our actual documents and malicious documents. And what you'll see here is that I have a document called Felina.doc. And what you'll see is that Microsoft seems to have silently patched this vulnerability to some respects in Microsoft Office versions that have checked into the mothership. So the way that this vulnerability works at a super high level is there's something embedded in this Word document that reaches out to an attacker-controlled server, which then kind of runs the exploit. What we're going to do is we're going to use some tooling that's available to us to examine this document and understand how exactly we know that it's malicious, and then we'll actually run it to show you what happens. So what we'll see, hopefully when PowerShell loads, oh my gosh, is that there's actually a suite of tools called OLE tools. So again, we go back to that object linking and embedding. These suite of tools are actually super useful if you happen to be a security analyst or anybody who wants to look at a document to identify if it's potentially malicious. So what I'll do is I'll just go ahead and go to my desktop here in PowerShell, and we're going to examine this document with these OLE tools. These OLE tools have a really cool tool called OLE ID, which will just give us some information about this document to just get us started on the path of like, hey, is this actually potentially malicious. So as soon as I go ahead and hit enter, what we'll see is that it's going to examine this document, and in just a little while, it's going to tell us some information about the document. First things first, we see that it's a Word document that's from Office 2007 and above. It gives us some information about the fact that it's not encrypted, so it doesn't need a password to open it. It doesn't have any macros at all, and it doesn't have any XML macros. So if you're ever needing to look at a potentially malicious document with macros, you can use this tool as well. But what it does show is that it seems to be linking to something external. There's some sort of reference to an external file in this document, and this tool has flagged that as a potentially high risk. And we can actually use another tool in this suite of tools called OLE object to actually extract what that external reference is. So I'll go ahead and just do that command. And what we see is that there's a relationship to an external link, and that external link seems to be loading some sort of HTML web page. What we see here is the IP of my attacker computer, which I'll show you in just a second. But we can tell quite quickly that this document seems to at least be referencing some external, potentially attacker-controlled infrastructure that may deliver this potential payload and attempt to exploit this vulnerability. So, as I mentioned, Microsoft has actually taken the time to do some soft patching around this. So any version of a Word that has checked into the mothership likely won't be easily exploitable using this method, although it's actually really trivial to bypass, and I'll show you how. So first things first, what I'll do is I'll go ahead and open this document. And what we'll see is that Microsoft Office will open, and we'll actually even see that it's going to go ahead and try to load this HTML file from the server. Sorry, things are taking a little bit longer than I would expect, but here we go. We're seeing that Microsoft Office did actually open the document, and it did actually talk to the server to try to retrieve this malicious HTML file. But as you can tell, nothing has seemingly triggered so far. But this protection, unfortunately, is super trivial to bypass, and I'll show you how. So all I need to do is literally go into Word here and just save this document as a different type of file. So we'll go ahead and give this virtual machine a second, and we'll go ahead and save this document, this current Word document, into a rich text format file, an RTF file. All I need to do is save this malicious document as a rich text format file. I'm doing so now. And what I'll do is I'll actually show you that it's exploitable by simply opening this newly created RTF file. So while the .doc doesn't immediately trigger the vulnerability, even though the malicious code is being retrieved from my Kali system here, the moment I open this RTF file, we'll actually see that the exploit does actually trigger. So immediately we see this compatibility troubleshooter is running, and it ran as soon as I actually opened the document. And in the background, what's happening is we've successfully exploited the system because we were able to open the calculator application. Sorry, this is a virtual machine. It's a little bit slow, but you can actually see, hey, we opened a calculator by just opening a document. And this is just a really common way to prove that you have the ability to execute things remotely on a impacted system. So simply by literally saving the file as an RTF, we can bypass the protections that Microsoft has kind of silently pushed to the Office productivity suite. That's not great. What we'll do as well is show you that it's actually super simple to review the contents of these malicious documents. And you don't even need some of these tools that I mentioned that are available in this OLE tools suite. That's because Microsoft Office documents, at least any recent ones since after 2007, are actually just zip files. And what we can do is actually just really easily extract the contents of the zip file and review the malicious potential objects. I'm going to actually do that with another document that we have here called reverse shell. It's also malicious, and we'll show you in just a bit how. But what we can do is literally just use an application like 7-zip or anything that can interact with a zip file to extract this document, which again, even though it looks like a Word document, is actually just a zip file that has a bunch of contents inside of it. So what I've done is I've just extracted the contents of this reverse shell document into a folder. And if we open it, we can kind of see the guts of a malicious Word document. If we open this Word folder, what we'll see is, hey, the contents of the document, so any text you and I may have typed, are just in this document XML file. There's stuff like the fonts that you're using, settings that you're using, styles within the document. All of that is just stored in these XML files. And these malicious references to these embedded or linked objects are actually also in this structure. So this rels or references document is actually something we can just open with any kind of Word editor. So I have here Sublime Text. You could use Notepad. You could use any kind of program that can read XML or Word documents or any kind of text. And all I'm going to do is I'm going to go ahead and drag this document into the Sublime Text doc. And what we can see is that the target or the attacker controlled server is actually just visible to us here. So if you ever find yourself in a situation trying to examine a potentially malicious document, you don't have these OLE tools or these things, you can literally just unzip them and take a peek. If you look at this Word structure, if there were any macros, you would actually see some references to VBA script or other things in this structure. So even if you don't have these tools available to you, you can quickly examine a Word document or a PowerPoint or whatever to determine if it could be malicious. Okay, so what we were able to ascertain is that there's this malicious server that seems to be loading some sort of HTML file. But what we probably want to do is try to understand what this HTML file has to understand what's being exploited. And the way that we can do that is we can use a program in PowerShell called wget or webget. And what we can do here is I can just type wget and give it this URL that I'll go ahead and copy and ask it to retrieve the contents of this web page. The unfortunate thing here is that this vulnerability actually is triggerable by loading this HTML file from our malicious server using wget. Sorry, my computer is being a little bit of a pain here and not letting me copy and paste. So we'll just thank the demo gods for the pain and try again in a new PowerShell window. Okay. All right, so this is going to be fun. We'll just do it kind of manually here. So all I need to do is type the actual file that we need to retrieve, which is here on port 8000. And all we're loading is a file called index.html. And what you'll see is that this can be exploited by literally just retrieving this potentially malicious file here. And as you saw, all I did was I hit enter. My computer tried to retrieve this potentially malicious file. And now the attacker actually has a reverse shell or literally has command line control of my computer. Just to show you what I mean, I can literally type who am I, and it shows me that I'm the desktop here on Fran's side. I can do things like find the IP address, normal things that an attacker may do. But just to show you what an attacker can do here, we can also do exactly how this is being exploited in the wild, which is we can actually just go ahead and kill this troubleshooter, because this would maybe be a sign for a user that something has gone awry. So we can actually just kill that troubleshooter if I can spell. And you'll see that this program will go away. So I was able to, as an attacker, just issue a command to this computer, and now I have kind of full control. And just to show you that I'm not kidding, we'll go ahead and just do this. So I'll go ahead and just copy and paste a PowerShell command that will actually pop up a little box on this computer telling us, hey, I really have remote control. Now, when this is actually being exploited in the wild by attackers, in their malicious code, the first thing that they're doing is killing that MSDT kind of pain that you saw, that troubleshooter. So often, if this vulnerability is being exploited, a user won't even have the ability to see that little troubleshooter that we saw pop up at all. Okay, so what we've done now is we've shown you that literally just getting this potentially malicious file is enough to trigger the vulnerability. It's not just a Microsoft Office vulnerability, but what we're gonna do is we're actually gonna look at this malicious HTML file a little bit closer to understand how this vulnerability is being exploited in the wild. So instead of just wgetting the file, which immediately triggered the vulnerability, we're actually going to go ahead and save the output of this malicious HTML file to something on my desktop called malicious.stuff. So all I'm asking this program to do is to just retrieve that file for me again. And instead of trying to show me the contents of the file, which is what triggered the vulnerability last time, all I'm going to do is go ahead and open the malicious file in this Sublime Text view. So this is actually the contents of the HTML that's being returned by the attacker server. Let's go ahead and just say it's HTML. And we'll find some particular things about this kind of immediately. First things first is that we actually see an HTML comment that happens to be a bulk of the content of this document. And that's because in order for this vulnerability to trigger, you actually need a file that's a certain size. So all that's happening is my malicious server on this side is literally just padding this HTML file with more useless data so that it's large enough to trigger the vulnerability. Okay, what we can immediately see here is that this HTML is loading a reference that uses the MSDT protocol handler. So this is what it looks like. MS-MSDT with a colon is what tells Microsoft Windows to use the MSDT program to execute whatever is being sent in this link. And what we can kind of tell kind of immediately is that there's a particular interesting bit of this code that looks to be just straight up PowerShell. So right here, it looks like this IT browse for file thing is actually what is injectable or being abused. So this parameter, IT_browse for file, is injectable with whatever arbitrary code an attacker wants. In our case, all we're doing is executing PowerShell, and I can show you here rather quickly. In fact, this is just, oh yeah, my pasting isn't working, so I can't show you easily, but this is just easy PowerShell. You can see, if you're familiar with PowerShell at all, invoke expression is a PowerShell commandlet or function that you can use. But what we can do here is try to understand what exactly this attacker is trying to abuse. And what we see is that there's this kind of strange string or text here that we can examine and try to understand. And what we see is that it's actually a base 64 string. So it's just a way to encode data in a way that doesn't have any kind of spaces, which is important for this execution. So you actually can't have any spaces at all in this document, or this unfortunate injection won't work. So if there's any space at all, this injection won't work. So what we're doing is we're actually taking a string, kind of like words that would have spaces, and we're using base 64 to make sure that it doesn't have any spaces at all, because that's what we need to do in order to exploit this vulnerability. And what we can do is we can actually just use some cool tooling that's available online. So I'm going to open Chrome, and we'll give Chrome a little bit of time to open. But there's a tool called CyberChef that was developed by the UK GCHQ. So kind of the NSA of the UK, their cybersecurity agency. They've built a tool called CyberChef, and I'm a huge fan of this tool. Highly recommend it if you ever need to examine content of anything malicious. But it actually has a bunch of operations here that I, as an analyst, may want to look at. It can do things like cryptography. It can encode and decode. It can do forensics and try to look for embedded files. It can do all sorts of things. But what we're going to do today is we're going to use a function that lets us decode this base 64. And all I need to do is just simply paste the contents of my encoded base 64 string. And we can see that what's actually happening is we're invoking a web request, we're downloading some potentially malicious file, and then we're saving it to a particular location. So C Windows tasks nc.exe. And then we're executing that file, which happens to be a program called netcat. And we're saying, hey, use this program, feed it the contents of the command prompt, CMD, and just talk to this malicious server. So without having to use any super secret tools or OLE tools, we were able to quickly determine that what's happening is this malicious HTML file being retrieved is loading this protocol handler. We're abusing this IT browse for file function to load our malicious PowerShell script. Okay, so this is not the end of the world. It's bad. It's triggerable outside of Office, like I showed you, literally just using wget or using any program that can kind of load remotely an HTML file will trigger this vulnerability. I also just showed you that bypassing some of the protections that Microsoft Office has built is super trivial. Literally just renaming a file to RTF actually executes the vulnerability. And unfortunately, it's a tiny bit worse. If you happen to be a person who enables the preview pane and you have the preview pane turned on and you load a RTF file just to preview it, this vulnerability is actually also exploitable. So what you saw is all I did was literally try to preview the contents of this RTF file with my preview in Office, or sorry, in Windows, and the calculator immediately triggered because it exploited the vulnerability. So there's a little bit of good news here, which is there's actually a few interesting forensic artifacts that are dropped when this vulnerability is exploited. The first one is, for some reason, the Office suite seems to write some contents to the registry. So you see here that I went to a particular location in the registry. We can share this afterward via chat. You don't have to write this down. It actually has a user ID in it, so this would be different for you. But what you need to know is that in the registry, anytime the Microsoft Office suite tries to load remote content from some remote server, it actually writes a registry key called server cache that has the URL or the host name that was actually retrieved from. So if you're trying to look for kind of post-exploitation forensics, you're trying to determine or hunt for, hey, has my environment been potentially exploited by this vulnerability? If the attacker was using Microsoft Office to trigger it, you can look for this registry. And if you're using any tool like endpoint detection and response, it's typically logging this registry information for you, so we can do hunts on that. Another interesting tidbit is that in a particular file location, so we'll just go to the File Explorer, anytime this MSDT program runs, this diagnostic utility runs, it actually seems to write kind of a debug report to disk. So all I went to was a shortcut to the app data location. This is just a location that is really commonly used within Microsoft Windows to write either temporary data or persistent data. But what we see is that in this diagnostics folder, there's actually instances of every time this vulnerability has been abused. So what we can see is, because I triggered it kind of a few times, we have a folder here that has a file that actually has the content of the command line that was passed to this tool. So in this XML report, what we see is actually the content of the path. So here is the exploit. Here is the PowerShell that was executed by an attacker. So we can use this other forensic artifact to look at and understand, hey, was this exploited in the past? What was the actual command that an attacker tried to execute, if we don't have tools like endpoint detection and response available to us? Oof, okay, that was a lot. So let's go ahead and go back to the presentation now that I've shown you how you can kind of understand it more in depth. Let's talk a little bit about current status. First things first, as I mentioned, Microsoft appears to have updated Office to prevent some exploitation of this vulnerability. Unfortunately, that's actually really easily bypassed. I showed you that literally by just saving a file in a different format, we were able to continue to trigger this exploit in Microsoft Office. There's other good news, which is Microsoft has updated the Windows Defender antivirus. This is not the EDR product. This is not the CrowdStrike competitor, but the antivirus that's available to all Microsoft Windows customers. They've updated the AV to have signatures for potentially loading of this malicious HTML. And while that's nice, unfortunately, researchers have found that this is also easily bypassed. So while detection is good, it's all easily bypassed in several ways that are now public. Another unfortunate thing is that Microsoft, as recently as 2 days ago, said publicly, hey, we're not sure if this is something we actually need to patch. It's a functionality that we need to have to help our customers troubleshoot, but it is obviously being abused. That's unfortunate. I think Microsoft will change their mind, but we'll see. So one thing that I mentioned is that it's not just Microsoft Office that's vulnerable to this exploit. It's actually a vulnerability in the Microsoft operating system. And what folks and security researchers have identified is that you can actually trigger this bug with other document viewing technology like Foxit PDF reader. So if you're using Foxit, it's possible to generate a PDF that links to a malicious web page in the same way that I just showed you, and it can trigger the exploit just like that. Luckily, Adobe, who's been hit pretty hard with all of these issues in the past, has pretty good sandboxing protection. That means that their particular PDF viewer is not vulnerable, but it's not just Foxit PDF. It's not just wget via PowerShell. There's a lot of different ways that you can trigger the loading of a remote HTML file that can attempt to abuse this MSDT protocol handler. Another thing that I mentioned is Microsoft has updated their antivirus to have signatures against this, as have several other organizations like CrowdStrike and others. But unfortunately, the way that those antivirus signatures work is they're looking for a full command line where it shows IT browse for file in the actual HTML contents. Unfortunately, this MSDT tool can actually load remote XML to have it answer what parameters should be passed. So instead of an attacker doing the MSDT with the full command line that I showed you, they can actually just point to an XML file that's hosted remotely. The MSDT tool will happily consume it, look at the contents of the XML and say, oh, hey, for the IT browse for file parameter, I just want to run notepad.exe. So these antivirus signatures and some of these other things that Microsoft has tried to do are also, unfortunately, really brittle. And as I mentioned, as recently as 2 days ago, Microsoft kind of publicly commented on the fact that they're not sure that they'll actually patch this vulnerability. But what should you do about it? The first thing is you shouldn't panic. There are simple ways to mitigate this currently. So first things first, there are simple and effective mitigations that you can deploy at scale within your Microsoft environment to stop and prevent this exploitation. Additionally, because what we're doing is launching a process from Microsoft Office or a PDF document, this is detectable using technology like endpoint detection and response, or just simply logging the contents of a process. So every time a process starts, if you're logging that into a SIM technology, or if you're using EDR, this is actually fairly simple to detect. So what can you do to actually deploy your mitigations? There's two simple ways to address this. The first is you can literally just delete that registry entry that tells Microsoft Windows which program to use for this MSDT protocol handler. So if you remember, I showed you that Microsoft has all of these protocol handlers and which program should interact with different protocol handlers like your email client. It's all in the registry. A fairly simple and Microsoft recommended way to totally mitigate this is by just simply removing that protocol handler altogether so that it can't be abused. Unfortunately, while this is Microsoft's recommended mitigation, it's a little bit hard to deploy at scale unless you're writing a script that's going ahead and backing up the file, the registry contents, and then manually deleting it all through a script. So sure, you could write a script, you could deploy it using whatever enterprise management tooling you may have, but there's an easier way that has been identified by actually the same author of Mimikatz, Benjamin Delphi, who works at a French bank CERT, identified another way that you can prevent potential exploitation using GPO. So almost everybody in the Microsoft world is using group policy objects. It's a super easy way to make this change at scale and make sure that it impacts your servers, all your Windows workstations. And what you can do is you can actually use a GPO, a group policy object policy, to totally disable the ability to run these scripted diagnostics. So what you see, and we'll link to a blog post that has how to do this in just a second, but what you see is that by disabling the scripted diagnostic capability altogether, it actually prevents the exploitation, because when MSDT tries to run, it actually just says, oh, hey, this has been disabled by group policy. I actually can't execute this, and you have some level of protection. Microsoft, for some reason, does not recommend this approach. They've not spoken as to why they don't recommend using this GPO, but there is some conjecture, and I just want to mention this is conjecture, which is that they may be worried about the fact that this is a tool used by their support team to provide remote support and remotely examine a computer that may be facing an issue. And if you disable this scripted diagnostics, if you ever reach out to Microsoft support, they may not be able to easily investigate what's happening on a domain controller or on an Exchange server or in whatever environment. Now, while that is a downside, I think that it's probably a worthwhile mitigation to deploy until Microsoft chooses to actually fix this vulnerability. Okay, that was a lot of talking and a lot of deep dive technical, which is what we were hoping to achieve. I want to open the floor up for questions if there are any. We'll also share our research post and our advisory that has some of these mitigation recommendations within it. But if there are any questions, feel free to use the Q&A function, and we'll be happy to go ahead and get them answered. Oh, I see a question in the chat. Yep, somebody mentioned that this is also deployable. The GPO is also deployable using Intune, which is great. If you're using Intune, which is really common nowadays, you can also deploy that mitigation there. Also see a question about, will we share the slides? Yes, we'll share the slides, and we'll also share a recording of this presentation on our social media after. And we'll also go ahead and share that research post, which has our mitigation and guidance recommendations. I'll go ahead and drop that research post into the chat now. And if there are new updates to this situation, we'll also go ahead and update that blog post with additional recommendation or maybe notifications that Microsoft has decided to patch the issue. Thanks very much for your time. I'll stick around for a few more minutes. We'll go ahead and stop presenting. But if you have any questions, don't hesitate to reach out. Go ahead and drop them in the chat or send them to me by email, which I'm typing into the chat now. Thank you, everybody. Hope you have a great rest of the day.